Good morning, guys. This is Mrs.Z. Today, we're going to talk about how to multiply 2 by 2-digit numbers by using area model, and also connect that to 5th grade, where they need to understand relationship between area model and the standard algorithm. So objectives are 4.NBT.5 for 4th grade and 4.NBT.5 for 5.NBT.5 for 5th grade. Number base 10 is what we are talking about. Okay, so let's see if we have problem to solve. For example, if I need to do 48 groups of 32, and I don't know how to do that, the idea is to use distributive property because the area is connected to distributive property because we're going to distribute numbers, and then we will use those in our areas. So if I have 48 groups of 32, I'm thinking, okay, I'm going to open parenthesis and I'm taking 40, decompose 48 into 40 and 8. And then also I'm going to multiply that with decompose 32. 30 and 2. 30 plus 2. So now I know what my area are going to be, what my length are going to be. So I like to use colors. So if I have the 40, that could be a yellow. And if I have 8 to be blue, just the first time would be a beneficial. And then 30 could be my pink. And then 2 can be my green. This is very good for ELL students because they're visual learners. Some of them are very visual learners. So now if I have my ruler and I'm going to pretend that this is, I'm going to make a parallel to the edge, so make it more precise. So I'm going to draw a line, and that line is going to represent my 40 and 8. So I'm choosing this part to be 40. And then this from here to here, I'm going to have 8. So now you know where those numbers come from. Okay, I'm going to also label them by my colors. So that is, and I need the blue. So 40 plus 8 is 48. So I have 2 lengths for my areas. I also know if I multiply 2 by 2, I will have 4 areas to create. So now I'm going to do the perpendicular line, perpendicular down from here. And then I'm going to choose, if I would like to match with my standard algorithm, I should use that second number to be on a side, and this fact. And then I will start with the smaller, with the ones first, which is 2, and then the tens. So I'm going to use this one to be a 30. Right. So now I have my areas. This is going to be my pink, and this one is going to be green. All right. So I have my areas there, and I needed to create a link. Sorry, I'm going to now create those areas. So I'm going to draw a line between 30 and 2. And I'm going to make line between 40 and 8. Perpendicular line will give you the best precision. So now I'm going to also close that areas. I can use my other triangle to make it perfect rectangles. So here are they. And I created 4 areas. 1, 2, 3, 4. These are used distributive parts. Then I'm gonna now do. So when I look this, and I have my paper, I need to tell kids that they are going to be just concentrating on one area at a time. Like take the paper and I just isolate everything. All I need to do is the length times width or width times length, and I will find what area of this part is. But also I like to use, so they need to find this, this, and this. So by parallel lengths, so this line is a parallel to this, and also in rectangle, this side is the same as this one. So I know then this is 2, so this is going to be 2. So I'm kind of making a little bit, so I know if I need only to do now that little rectangle area, I know then I need to do 2 by 8, 2 times 8. Or this one, I will do 2 times 40. Okay, now I have this length of rectangle is the same as this, parallel and congruent. So this will be as well 30. And then when I look, the top one is 40, this line, so is that the bottom one? So that is also the value is 40. So I like to put really 40 there, so I know that all the lengths that I'm using. This 8 is same as this length. That means this is also going to be the 8. When I go and do that, then I can go and solve my areas. Length times width is formula for area, long side times short side. So I need to think 2 times 40 or 40 times 2. So by this, I already have a 0 that's multiple of 10. I know then this is 4 times 10. So I can think of 2 times 4 is 8, and then times 10 is 80. So what that does is that when I multiply by multiple of tens, the number gets 10 times bigger and gain a 0. So, and that what 2 times 4 is 8, and I can just add a 0 to the product because I multiply by 10. I'm done with this. I'm going to circle it so area is done. I'm going to go to the next area. So now I have a green by blue, which makes 2 times 8, and 2 groups of 8 is 16. So I know that this is 16. So 2 times 8 is 16. So this area is 16. Now I'm going to go in, move to the bottoms areas. So I have this one here, and that is 30 by 40. So in this case, I have 2 zeros. I have 3 times 10, 30, and 4 times 10 is 40. So what that tells that I can multiply 3 times 10 times 4 times 10, which makes 10 times 10 is 100. So I can add 2 zeros to my product. From this 4 times 10 is 1, and then from here also 1. So that can go directly to my product. All I need to know what is a 3 times 4, which is 12. So this means 3 times 4, a commutative property of multiplication. If you want me to see just additionally to understand it, I can explain to you. If I have 30 times 40, I can do 3 times 10 times 4 times 10. I decompose, and then now I can commute. I can do 3 times 4, and I can do 10 times 10. So this is the 100. 10 times 10 is 100, and this is 3 times 4 is 12. So 12 times 100, 12 gains these two zeros because it gets 100 times bigger. And that's how we know that this is 1,200 or 12 hundreds. The last but not least is 3 groups of 8. 30 times 8. 30 is 3 times 10. So I only need to know 3 times 8 and then add a 0. If I don't know what 3 times 8 is, I can use a thinking blocks. I can think, oh, I don't know what 3 times 8, but then I can use a meaning area. What if I say this is 3 times 8? I'll break into 5 plus 3. So 5 plus 3 is 8. So that helps me to skip count by 5. 3 5s is 15, and 3 3s is 9. Together, 15 and 9 makes 24. So I can use that 3 times 8 is 24. This is a side thinking of. So when I have all the areas done, I can now add these two parts, so which 80 plus 16. If you needed to work on a side, you can do that as well by adding 80 plus 16, and that is 696. So this is equal to 96. And then if I am going to add these 1,200, I can use my highlighter to make my place value distinguished. So I can add a 0 for 240. 240 does not have any thousand, so I can add 0 to hold the place value, and I can add those together, so that becomes 1,440. So if I look this, and I would like to make a precision, I can also add the lines between, and then I will add this value 1,440. So 1,440 is my other number. So if I add these two together, they will give me what this multiplication, what product is. 6 plus 0 is 6. 9 plus 4 is 13. I remember I made 100, so I can add whatever I like. Then this becomes 1 and 4 makes 500, and I have 1,000. When I have all the numbers in a place, I can say, okay, ones, tens, and hundreds, they make period of ones, so that I need a comma there. So my number is 1,536 as the answer. So how that can connect, so I can go and write answer there for my product. So it is, my product is 1,536. Not and, sorry, 1,536, because if you say and, you have decimal, but I don't. Decimal is right here at the end, if I needed to think that way. So now, how this can connect to the standard algorithm, which is shorter version of multiplying two numbers. So I will have 48, okay, and I need to multiply by 32, by 32, 32. Okay, without knowledge of rules. to multiplication, you can see that this number 80 plus 16 is a partial product of, it's actually two groups of 48. So that is the first part of the standard algorithm. 2 ones times 48, 2 times 48. And you can see that that is going to be 96. The next part is going to be 30 times 48, and that is 1,440. And now we're going to prove it. If we start with a rule that when we multiply the standard algorithm, we say that ones needs to multiply by the every number on the top, ones by ones and ones by tens. So 2 times 8 is really 16. I can write for kids 16 right here, but I'm not done with the 4. So that 1, it has to go and say, I have 110 to remember. So 2 times 8 is 16, 1 and 6, 16. And then 2 times 4 is 8. So 8 plus 1 will give me 9. So when I have that, you can see I like to put lines in between, so then I can stay in a place value order. So that is connected. This is 96. That these two parts are the first number in a standard algorithm. When I move to do now 3, that means I need to also think that this is not a 3. That is a 30, 32. So I needed to add a 0 for 30. So here is the 0 that represents that 30, 30. And now I can use the rules saying, okay, now I need to do 3 with every digit on the top. 3 times 8 and then 3 times 4. I am done with this, so I cross it off. So I can add the 0 for 30, and I can say 3. Now I need to start writing here. 3 times 8 is 24. So if I think about this, that's a 24, but I'm not done with 3 times 4. And so that 2 is going to be remembered or made. So now I have 3 times 4 is 12 plus 2 is 14. So now I can add these two values, and that will give us the value of the standard algorithm multiplying 2 by 2 digit. 6 plus 0 is 6. 9 plus 4 is 13. I made 100. 100 plus 400 makes 500. And that is 1. So the product are the same. And these two parts of the area are this. And they are the second number in the standard algorithm, which means that is 2 groups of 48 is 96, and 30 groups of 48 is 1,440. Together, they are 1,536, and that is the product of the 2-digit by 2-digit. Okay. You can also connect this with the distributive property. So distributive property is important as well. If you are working now and you're going to do 48 times 32, to use distributive property, you can connect with the area model by saying, okay, I'm going to distribute 48 into 40 plus 8 times also 30 times 2 plus 2, sorry, 30 plus 2, messed up, And then I'm going to use undistributed property by saying if I distribute numbers, I have to multiply each number by each number from one parenthesis to each number in the other parenthesis. So if this was my 40, I'm going to do 40 times 30 and then 40 times 2. So I'm going to say, all right, 40 times 30 plus 40 times 2. I'm also going to add now 8 times 30 and then 8 times 2. So now when I do that, I can see open parenthesis 8 times 30 plus 8 times 2. 8 times 2. Now I need to solve each product here in parentheses. So I can see, oh, this is 40 times 30. It has a 2 multiple of 10. So 10 times 10 is 100. I can put these into the product. All I need to know is what is 4 times 3, which is 12. Now add, and that is connected directly to this area, 30 times 40 or 40 times 30, 40 times 30, correct? Now 40 times 2 is 80 because I have 1 0, which is from the multiple 10, 4 times 10 times 2, which 4 times 2 is 8, and add a 0. So if I have my I can also show this way to the student. Now I can see that is this one. 2 groups of 40 is 80. 2 groups of 40 is 80. Plus 8 groups of 30. 8 groups of 30 is also 8 times 3 times 10, which 10 goes in my answer, and 8 times 3 is 24. So that is the area. 30 groups of 8 or 8 groups of 30, and that is connected to the distributive property. Plus, now 2 groups of 8 or 8 groups of 2 is 16. And when I have that, I can do the whole number addition. I can add these two if I want to. So that will be the 1,280 plus I will add these two, which will make 256. And then when I, oops, sorry, you can see, when I add this, that will make 1,280. And when I add 240 plus 16, that's 256. And guess what? When I add these two, they will make 1,536. So now you can see how these, so this is area model. This is standard algorithm. And this is distributive property. These are the three strategies that you can use with the students and make sense which one is the best for them. Does the distributive property make sense to them? Or the area model makes sense to them, or the standard algorithm is making sense to them, especially if they are good in multiplying facts. So all this was to find what is the product of 2-digit by 2-digit, which our product is answer for multiplication, and this is 48 times 32 is 1,536, and this was Mrs. Z. I hope that this makes sense to you, and see you next time, guys. Appreciate you. Make smart choices and be happy.